I'm Matthias, working for Concentring consulting company, doing mostly data analytics, data architecture stuff. So not too much into search, but maybe something else here. Who of you has heard about DuckDB already? So, okay, I think it's hard not to hear about it, I guess. Who has already played something with DuckDB, used it for a bit? Okay, so maybe I can give you some new perspectives. Maybe you say, nice, Matthias, I have some new perspectives. How you use it, I would be curious to hear about that as well. I just give a really quick intro on what DuckDB is, but as I kept in the abstract, I will go into some more other use cases later. So DuckDB is a fast, in-process, analytical, open source, portable database. I think the bingo card, you can check quite some things here if you see this on the homepage. So I think fast, in-process, yeah, it's embedded, analytical, made for analytical queries. We come to this later. Open source and portable. I think the easiest way to show a bit about DuckDB is a demo. And please pray to the demo gods today. I think the talk has quite some demos. This morning they worked all. Hopefully it will be later as well. So we start with just simple DuckDB. I, in this case, installed it with brew. So just homebrew install DuckDB. And we just start the CLI, and I give it a UI flag just for demo purposes. It just starts a simple UI with it as well. DuckDB is pure SQL, so everything SQL. One of the inventors, Hannes Mühleisen from originally Germany, also had a car once where he's from Stuttgart and had the second letters QL, so SQL as a car, as a license plate, so you see he's really into SQL. So yeah, we can analyze JSON files that are stored here locally, just select star from read JSON. We can do some aggregates on it with the group by all clause, right now widely distributed over query engines. DuckDB was actually the first one who started with this. We can analyze files that are stored remotely, in this case some Parquet files stored on GitHub, so retrieved over HTTPS. Of course, also all the grouping on this. We can read JSON that is more like from an API, I would say, looking at the URL. Hopefully works. Yeah, so, and one could also go then into the details again. One can also analyze things stored on a blob storage. I think this wasn't needed. I only need this one because I'm underneath using the AWS CLI and I'm already authenticated. So if I now say, hey, please read something from S3, in this case, some JSON gzipped files, a bunch of gzipped files, you can just query those data and do some SQL on this. So if you're ever coming to the point where you say, hey, somebody gave me some Parquet files, for instance, or a bunch of JSON files, or really big CSV files, just start DuckDB, use SQL. Fine, you're done. Really easy. It is even, not part of the demo, but it has even one of the best CSV parsers. I think there's a ranking about malformed CSVs, how good everybody can parse this, and DuckDB is most of the time at the top of this, so really like missing values and additional values and so on. And somehow he always managed to parse those. So, analyze. DuckDB itself is really portable, so what you have seen now was the command line client, but there are drivers basically for everything what you would think of. There's a Python one, this is most likely the most popular, but there's also a JDBC driver, an R driver for the TypeScript JavaScript ecosystem, the one with Brew you see for Rust. So DuckDB itself is just a small C program with a lot of extensions. So what you've seen before, the querying versus HTTP is an extension. Querying JSON is an extension. Querying Parquet is an extension. And all those, the main extensions, the most important ones, are just auto-loaded as soon as you see them, as soon as they are used. So DuckDB is really flexible. It can read a lot of file formats, also the newer ones like Iceberg and Delta. It can write most of the file formats. Delta write isn't so good supported. Iceberg writing is getting better and better all the time. It can read from all the blob storage, from HTTPS. It can also read from MySQL, from Postgres, from SQLite as well. And it's really easily to integrate also with pandas, numpy, arrow. So you can just say, if you use the Python client, execute a query, and then you say 2 arrow or 2 polars, and then you just get this result as a polars or arrow table or data frame without explicit conversion in between, just moving bytes in memory. Okay, but some more demos. As I was here at Berlin Buzzwords, I thought I started with some simple log file analysis. You might know I always use bash tools for this, or I have everything in AWS, or in Elastic, or some Solr underneath, or whatever. So we have just let me quickly make it a bit bigger for you in presentation mode. So we have, I have a small log file here, 2,000 lines of Spark executor log, just as an example. And using this with DuckDB is basically just, so with DuckDB -c, you can just execute a query directly with DuckDB. 2,000 lines, okay. And with this one, as you see, we just use regex to pass those lines. If you have a JSON as a log output already, even better, then you can just use read JSON instead of read CSV here. Yeah, and then just have this as output. Really, really fast. I showed this DuckDB once at an insurance company, and I know there were a lot of things into DB2 and really love DB2 and everything. I was like, oh, most likely I will get some backlash here because they think, hey, this is not a real database. You have to use a real database like DB2. And I think one day later I got a message from them, hey, thank you. We really use DuckDB to pass our query looks from DB2. And DuckDB was the only one that did it in a reasonable time eventually. So they were really happy also for this one. If you see, hey, no, I want to use it for further bash processing and apply something, no problem, just pass the CSV flag and you get it as CSV. Or if you want, use JQ afterwards, just use JSON as the result. Okay. Then, next one. I keep it short. DuckDB for AI data access. This is the only AI part in this demo, I promise. I have some files again here in MCP. There's a Parquet file, and I would just say, give me the key insights from NYC sample Parquet. And as you see on the right side, you have some MCP servers. The one thing is DuckDB in memory. And as you see here, he just starts executing queries in DuckDB in parallel, spawning several agents, and in the end, giving us an overview of the what he's found so far. One can, of course, argue if MCP is the right thing. If you just have DuckDB as CLI installed, totally fine, just use DuckDB in the CLI underneath. There's no added benefit in this from an analytics perspective to use MCP, just that you don't have to install a CLI. So if you, so gives us some stuff on here. One can also do the, of course, the S3 part using DuckDB. In this case, it's using my AWS CLI underneath to authenticate, but it's basically the same thing, just in the query instead of read CSV, some local path, read Parquet, some remote path for Parquet. So. More interesting, DuckDB ETL in a Lambda function. I think most of you know this. You get some data at some time. It's stored in an S3 file, and then you start a job to clean the data, load the data, store it in some data lake or in a database or whatever. And sometimes you use a heavyweight Spark job for this or something else. I would propose just use a simple Lambda and use DuckDB in Lambda. So going into this, first show you the function itself. So I've written the Lambda in Python, just because I'm way more fluent in Python than anything else. Just a simple handler here, and as you see, we install HTTPF and load HTTPS as an extension. Made it explicit here, not even needed anymore because this would be auto-loaded as well. And then we basically just have this execute step. So select row number, do some trimming, casting, lower and so on. So just some simple transformations on the data we get there from read CSV, the SV put that we get as an input here from the handler in the context, and then copy this one, the output of this query. So this is the query doing the actual transformation, copying the output to an S3 bucket again. That's it. So really, really simple. Demoing this as well. Going into the Lambda stuff. So it's the decay. And I'm lazy and just copying over the commands because they're a little bit longer because of the bucket names. First, so that you believe me that I didn't put anything in the output bucket. I remove everything from the output bucket. There was actually something in there. Then let's tail the logs of the Lambda just to see if something happens there. And in a new window, upload the S3 files to S3, sample data CSV, and we use DuckDB, of course, again, to look in the query if there's something else. So it takes roughly 10 seconds until it's processed here. You see the log. The file was processed in the Lambda file. And if we do a select here, no. Just needs the credential again. So there it is. So really simple ETL stuff, loading data and stuff, just and really, really fast. So this was not a big file, of course, but even a big file, it doesn't have any problems with DuckDB. Now you might think, okay, using DuckDB for ETL sounds quite of nice, but I have a lot of Spark jobs already and have written really, really a lot of PySpark code. Might be at some companies. And rewriting all this stuff to SQL, nah, I don't know, would be quite some effort. I have some example here. There's a Spark job, creating a Spark session, read the parquet file, do some filter with columns, and here doing some aggregates as well, some group by, and writing this to a parquet file. What would you expect? How long does it take? I mean, this is MacBook M1, 32 gigabyte RAM. The file is 1 million rows. What would you expect? How long does it take? So first of all, it's starting things. Spark always takes some time. Loaded the rows. Okay, now written. So 7 seconds in total. And I was fair and we left out all the, and so the second one is the slower one is after creating the Spark session. So Spark session already created, and then just the execution time, 4 seconds. And then there's a library called SQL Frame. SQL Frame is basically offer you the PySpark compatible API, basically PySpark, and transpiles to SQL underneath, and then you can say an engine to execute this. And by just adding those 2 lines here from SQL Frame import activate and activate the engine DuckDB, I start this now. Done. So 1 million rows written with DuckDB, and I only added 2 lines of code. Really, really fast, and I know quite some companies that improved their Spark jobs quite a lot with this. One disclaimer, of course, this effect, like from 6-7 seconds down to whatever milliseconds, is quite also because I'm using open source PySpark here. If you use PySpark in Databricks, PySpark in AWS Glue or whatever, they most of the time have tweaked the engine within PySpark. So for instance, if you use the Databricks PySpark, you will likely not get this kind of a speed up, but you will get some speed up. Because especially if you use Photon with Databricks, for example, it also already uses vectorized operations underneath, which is in the end what DuckDB makes so fast. So yeah, if you're on open source PySpark, I think this will really help. You've also noticed there weren't no joins in it. It's not because joins aren't supported by SQL Frame. It's just because I was lazy and didn't expand the example so much, but it would also work with joins. Yeah, there are sometimes things where you have to do some tweaking as well, but I think 95% of the code works pretty well directly with SQL Frame. Okay. So we had the ETL part, first doing it in a Lambda, or if you have some Spark workloads, just replace those with SQL Frame. Another part is not using DuckDB for the classical analytic ETL stuff, but when building applications. So think building an application where a user has some interface, some dashboard, and wants to do some analysis, and you provide it in your application, and you start by, hey, I have all my data in my Postgres already, just add a view on it, or maybe some index, or load the table somewhere else, and then build some analytics interface on top of it. At some points, the database administrator are going to come to you and say, hey, what are you doing with our relational database? All the queries here, long-running queries, all analytical style queries. Yeah. And so I want to show you how to maybe use DuckDB to create those applications, those analytical application. First, in the traditional 3-tier way. So we have a user using a client which is in a browser, just some website, then a server. In this case, I will use some Python fast API server, and then accessing data. And the data is not stored in a database itself, but it's just stored on a blob storage. Given that maybe you update those analytical reports nightly anyways, so just write every night your S3 into the S3, your Parquet file or whatever, and let the users query it. I mean, most of the time it's not real time. And even if it's like 2 times a day or 3 times a day, it's still simple. So, this one first show you the application. So running it with CDK in backend. So we run the application, open this in the browser. Just a simple app. It's a taxi data. I think everybody has seen the New York City taxi data by now in some demo. Number of passengers, the fare, and doing some stuff. You see the query underneath, that doesn't change a lot besides the passenger count, the fare amount. I think this is the only thing in the clause. Yeah, and you see the table. But it's quite snappy, I would say. And what was built here next to the index HTML was the main py, and basically it's just query taxi gets the query parameters and says, builds the SQL string, and in the end, DuckDB SQL gives the SQL back, and then the results are here. So, and then doing some mapping and returning this as an dictionary with the SQL, the calls, and the rows. You could return whatever you want. So for DuckDB SQL, as you see here, you can go to polars, you can go to pandas data frame, you can go to arrow, whatever you want and whatever you need. Really, really simple. One could also go, so DuckDB in the backend, query engine is in the backend. We basically separated our database that we had before. We had the storage just in the blob storage, and moved the query engine basically to the backend, to the service itself, and used DuckDB to query it again. Storage could be quite cheap, object storage, not some database that's running all time and idling. And the backend could be run in one instance. You could just start it if it's needed. Maybe those analytical facing, this user facing analytics is done once a day by some person in the morning when putting their coffee or getting their coffee. But it's still the classic 3-tier architecture. I still have storage, I have a backend, I have a frontend. But what is if we could go beyond 3-tier data architecture? So not even having a backend. We just have the user interface, which is a web page, and we have the database, which is our Parquet files. So look into this. And also there, I will first give you the demo, and the folder already suggests how it's done. Open in the browser. Same API, looks exactly the same. Also working like this. But more maybe an interesting part is more like showing the developer console, reload the page. So we have the network access done now. So it's loading the Parquet file here, sometimes making cross-site scripting requests to it, and everything else. If I clear it now, you won't see any more network requests. Just locally in the browser, really, really snappy there. So it's built with WASM. So DuckDB is also compiled as to WASM, and you can just include it in your web application if you want. There's actually quite some examples doing this. For a time, it's not anymore, but for a time, for instance, the Hugging Face dataset browser was built with this, but there's also quite some other examples for this. I said earlier I built it with Python, the one solution. I built this one with TypeScript or with JavaScript. The honest answer is I didn't build it. Open Code built it for me. Just want to build a demo. So if you see some TypeScript code now that you say, how can someone write this? Just forget about it. I know what it does, but I don't know if it's really the best version on doing this. So index.html, I think just some HTML parts. The interesting part is here, the run query. Just uses the SQL, and the run query is in here. And what you see here is connection query SQL. The interesting part is more, so the init DuckDB. So you get the WASM bundles. That is why it's taking a little bit of time in the beginning. You might have noticed it where it's downloading the WASM bundles and then using this in the browser. And there's a register Parquet. There's multiple ways to actually do this. In this case, we register it as a URL. So the Parquet file is accessible from the WASM sandbox in a URL file, but you could also upload the data into the WASM sandbox. Depends a bit on the use case. So of course, it comes with some limitations. I mean, it's WASM in the browser, so it's single-threaded. WASM has, depending on the browser, some memory limits. Most of the time, it's around 4 GB of memory that it can use. So might be enough. So if you're using Parquet file underneath, DuckDB is more than smart enough to not load the whole Parquet file into the memory, and so on. It's of course, it filters stuff, does predicate pushdowns, uses all this stuff. If you use Iceberg, of course, it uses the metadata available in Iceberg, so on. And yeah, you don't have direct local file access. You've seen what I've done. You have to register it. So you can't access files that are available for that are on the user's computer. You can build a dialog that they can upload those files, so that if they want to use local files for analysis as well, they can do it. One pretty popular example, for instance, is not shell.duckdb.org. It's also a WASM shell just running in the browser. And for instance, here you could also import data. If you click on import, it just opens the file dialog. And you could easily run any analytics on this. No need to install anything, just running it in the browser. So this basically says, hey, from a typical analytical application, how they're built right now is like, as I said, customers, you build a web application, the customers coming to this, and they all hit the same backend database that's also powering your operational system. And with DuckDB, you might have the chance to build something more like this. You have a customer going into a web application. Each customer has maybe its own database, translating to a file somewhere, a Parquet file. Could also be a DuckDB file. DuckDB has its own database format as well, if you want, stored on a blob storage or so on. You can have the web application started for every customer. You can have one for many, depending on how you deploy it. You've seen this example as well in using DuckDB in a Lambda could also be an option if you say, hey, every customer just gets its own Lambda started as it needs it, and otherwise it shuts down. But you would be quite flexible because, hey, it's just a library. Put it wherever you want it. But it's not only a library anymore. So I was quite lazy. prepared the talks 1.5, 2 weeks ago, started working with this, starting preparing the talk. And I was actually lucky because they made some announcements and I was then pretty much, it was easy for me to integrate them in the talk. The one thing, already a year old, so not the new one, is Duck Lake. So they keep to the naming schema, we'll see later as well. Who of you has seen any of the icebergs talks here? I think there are plenty. Yeah. I think this one might have been shown there. I think in the first one this morning, as it was actually said, hey, I'm the one that doesn't show this picture in the iceberg talk. This is what it was meant there. So iceberg, having a catalog, having all the metadata, and then the data and data files. And the guys from DuckDB said, hey, great idea, data files in Parquet. I think we should do this too, but metadata, I mean, you want to query it with SQL. You want to have, the one above is only because you need some transaction to set the pointer. This is the only reason at the beginning, right now it's expanding, to have this database, because you need a pointer to the current metadata file, and this needs to be an atomic transaction. So they use the database for it. Why not put all the metadata in a database? Why distribute it over a bunch of JSON files on a storage that is not meant for single row access? So they just said, okay, let's use a metadata database. Could be anything, could be Postgres, could of course be DuckDB, and store everything there, and have the data files underneath. This is pretty much what Duck Lake is about. It's the same thing as Iceberg, the same thing as Delta, just put the metadata into a database. Of course, in detail there are differences, but it does also snapshots, it does transaction, you can use it for time travel, schema evolution, so all the stuff that all the new table format, the modern table formats give you. The other thing they announced 3 weeks ago now was Quack. So, yeah, that. And the story is basically, you have a DuckDB instance running embedded. Now maybe you want to run it as a server and have another DuckDB instance connect to it. How do they talk with each other? How do ducks talk with each other? Via Quack. So Quack is basically the protocol to connect to DuckDB instances. It's an HTTP-based protocol. So in this case, for instance, we have a client here, the server just calls Quack serve, and then the client can connect to it and work with this. Of course, there's also a demo for this. Just close this one. And I'm lazy again. So I will just copy and run it and then explain what it does. So we start DuckDB here and run all this. So the first thing is we install Duck Lake as an extension. Then we say, hey, create attaches to some database. You can, if you don't do it, you just see you running in the database memory. You can attach to whatever database you want. It could be a Postgres, you could attach a Parquet file as a database. In this case, we attach a Duck Lake as a database. The Duck Lake is basically you give the path to where is the metadata of this Duck Lake stock, so the database that was shown before. In this case, hey, just use analytics data.ducklake, then it knows, it's a file. Then I will use DuckDB for it. So this is basically a DuckDB database now that was created as a file. And this stores the metadata for the tables. And then say use analytics data, and then we say, hey, in this database, create a table taxi trips. And as you see, DuckDB has some friendly SQL. I don't need this select star, just type from whatever, done. And it's not even needed read CSV, just to read CSV file, and he will figure it out that it doesn't that it needs read CSV. I think they also say sometimes, hey, we don't say we are the most, the fastest, the best, whatever database. I mean, everybody claims here's the fast database. They say they are the friendliest database. I would say that holds true most of the time. And then we call Quack serve, just, say, hey, we just know serve on the local host with the Quack protocol, and you need to give it a token. to authenticate content. That is the default. And we also say quack identify, then it writes something in the metadata. We will use this later. And then we use the second DuckDB instance, and also again everything. So we create a secret, super secret, of type quack, so used for quack authentication. Then we attach to quack localhost as a remote. So we attach a database, naming it remote, and it's running basically on a server. And then we say, hey, from remote query, select star from analytics data, taxi trips. And then it gives us the data we have just written on the server. So quack is still a beta, 3 weeks old, I guess. They already said, hey, we will improve this syntax so that you basically just write select star from remote.analyticsdata.taxi-trips, so that you don't have those unnecessary remote query stuff. The who am I gives us, hey, who am I as well? I'm nothing. I didn't provide anything. I'm up since 14 seconds, not even 14 seconds. What is the time step now? And if I go to remote query and say, hey, then it says, oh, yes, I'm another process that I started before and gave the metadata to it. And we can also maybe have a look here. Show tables. This is the only one that is there. But if we show databases, so there's also this duck-like metadata analytics data. And if we use this one, no, not use databases, use this one, and show tables, then you see this is all the metadata from the metadata database. Things that Iceberg and so would store in files, they just store it in a database. You can just query it. There's information about the Duck Lake table. So there's one table, snapshot, which is the first snapshot and so on. You have the snapshots information. So we have 2 right now. Yeah, so just all the metadata there and available. And of course, we can also run the server now against this. Surprise, if you can run an CLI against the server, we can also run, in this case, it's the backend server against it. You can also run the other against it, of course, and so same one. And as you see, the query here just has added this from remote query, then basically doing the same query as before. And in the code, it's just added these as the first step. We do connect to the DuckDB server. Just create a secret, attach to it as remote, and then we are done and running this. So to this is what we basically had here. We had a DuckDB client, we had a DuckDB server, and the server uses Duck Lake with a DuckDB database for metadata and Parquet files for storing the data. By the way, those files are here. There's a Parquet file storing the data, and this is the metadata, basically. Of course, in a production setup, you would use some other database. You would use a Postgres, or you can use a DuckDB database with Quack as well, or you can use whatever SQL compliant database you have. And for storage, you can just use whatever stores your Parquet files. Could be S3, could be local file, could be, yeah. So why would I use it? So this is really like then made for analytical workloads. You use DuckDB as a query engine. You can do post-process before inserting. So for instance, think about you have an application that also writes stuff and so on. And you want to aggregate those stuff first, and especially if you have some sensor data or collecting some data and just want some analytics first and then just store some of those data into the server. You can have DuckDB at the client, pretty powerful. A lot of things on the client, aggregate the data there. You can also, when reading, you can create a temp table. Just create a table in the DuckDB instance that you're running on the client, which will be in memory if you don't say anything else. And and just use this one as a caching table, basically, if you want. I think this is such a valid use case that the DuckDB guys always said, hey, you can also do a local read replica, so start a second instance next to the server and just say, hey, behave like a read replica, and then everything is just synced and you can read from it. They actually plan to integrate this natively into the Quack thing. So what to do with DuckDB? One thing, local prototyping, exploration. You can use it for single node data processing. Before there was always pandas, which was limited in memory, or PySpark, which was heavyweight, and now we have an option in between called DuckDB. To be fair, Polars would also be an option most of the time. And the other part is those simpler data-driven applications. And I want to end with one example. The customer, they were doing sensor data, storing sensor data, and it was a bunch of JavaScript developers, so more like the classic web application developers. And they were like, hey, we just store the data, all the sensor data in a DocumentDB because it's JSON, and then we can easily query it from a from a UI. And at some point we said, hey, yeah, the master data, which sensors do we have, where are they belonging to, we store in a database, in a relational database. And then came, yeah, we need to aggregate those data, we need to do OLAPing on those data, and they built microservices querying this data. And then at some point, some data scientists came and say, hey, we want to do analytics as well, but document database? Yeah, okay, we offload everything to a separate relational database. And what they actually built was a web application that is a data platform within a UI in the end. Now, we've seen this quite often, not in every domain, but especially in this industry domains where it's coming to sensor data or something. This basically you build data platforms within UI. And we changed it to ingest into the data platform, do everything on this data platform, aggregation, auditing, have a document database still in place, but just to show the data, so the document database is filled from the data platform, and the data analytics just works on the data platform. And those shift left in data flows is pretty often this time. So before that was, we have an application, and we're living in an application-centric world. Everything cares about application nowadays. And you do ETL, ELT process to load data in the data lake. The analysts are the second-class citizens in those process, and have to beg for the application developers to finally provide this data. But it might change to this. We have this data platform, and this is basically serving everything. So we are more data-centric in this. What has it to do with DuckDB? I think DuckDB is one of the technologies that actually enables to think more and build more like this. Think about the application building on a data platform. If you have a data platform, we'll likely use Delta, Iceberg, or whatever underneath. With an application, you have easy access to the data if you want. So I think this DuckDB thing is part of a bigger shift that we see. To be fair, not everywhere. I also showed it at an insurance company. The insurance company looked at me. I built just a regular insurance company system, like an Antrag, so getting access to an insurance or whatever, or closing an insurance, and I don't see it this way. But for more data-heavy use cases, I'm pretty sure this will do something. So what I take away from this, I think it's not only for analysts, also engineers, software engineers, building applications. I think DuckDB is quite interesting for analytical or data-driven applications. It could be used to really power large data pipelines, not only the exploration stuff. Really friendly to use, friendly database, the friendliest database, I'd say. And one thing, they might go for basic transactional workloads eventually. We had this discussion already. So there's the OLTP, there's OLAP, and then there's this HTAP. They say, hey, something in between. And if you're more curious about this, maybe watch the announcement of the Quack protocol in the last 5 or 10 minutes. Then Hannes Müller made some interesting, shared some interesting ideas that basically Postgres is the all-purpose. You can put it like everywhere database. That like things like Tiger, Beetle, which are really high process, high throughput systems, are more like the OLTP database, and DuckDB is the kind of an OLAP database. And OLAP is coming to the Postgres space. So because with the Quack protocol, they also have some benchmarks about really doing small inserts, not only the analytical stuff, big inserts and big chunks, but small inserts, small selects, only retrieving a few rows. And they were quite fast, so might think that they want to expand on this. And given that they just started as an embedded database and now claiming more and more stuff, bringing innovation to the field with the Duck Lake, for instance, I think might be a thing that happens. So, and the other one takeaway, if you're interested in code slides, find it in the notebook. That's it. Thank you.